In order to start the discussion on polar versus nonpolar molecules, we really need to make sure we understand the concept of polar versus nonpolar bonds. So I want everyone to write down what I have at the top of the page. We'll start by talking about what it means to have a polar bond. A polar bond is when we have an unequal sharing of electrons between two nonmetals. Now, hopefully, the fact that sharing and nonmetals are in caps and underlined is sending off all sorts of bells and whistles right now. If it's not, it should be. We said from the start of the unit, bonding is all about electrons, and electrons are either shared between atoms or transferred. And whenever we talk about sharing of electrons and nonmetals, two nonmetals, we're always talking about a covalent bond. So this entire concept of polarity focuses on only covalent compounds. And with a polar bond, we have an unequal sharing. If any of you have brothers and sisters, then you are very familiar with the concept of unequal sharing. Usually when mom and dad say, you guys have to share, that means somebody gets whatever it is you're supposed to be sharing more than somebody else. I have an older brother and a younger sister, so being the middle child, I was usually the one getting less than 50% of whatever it was we were supposed to be sharing. In this case, with bonding, we're talking about electrons. So when you have two different nonmetals of different elements, they have different electronegativities and they will never share equally. So a covalent bond between atoms of two different elements is always going to be polar. A nonpolar bond, by contrast, is when we have an equal sharing of electrons. And an equal sharing of electrons only occurs when you have a covalent bond between two atoms of the same element. And you'll see that unfold as we go through the examples. I'm going to review a little bit here because I can't stress these terms enough. Molecules are covalently bonded substances. There's only one scenario. We said there are 4 scenarios for having an ionic compound, only one for having a covalent compound, and that's when you have 2 or more nonmetals. The terms molecular and covalent are synonyms. They'll be used interchangeably throughout the year and on the Regents exam. So make sure we remember that throughout this entire discussion on polarity, we are only talking about covalent molecules, molecular compounds. So we'll start with polar molecules. And I said at the beginning of the unit, this is a very geometric concept, the concept of bonding. So I'm going to use the term asymmetrical. Polar molecules are asymmetrical. I want you to think of a magnet. Think about the poles on a magnet. A north and south pole you would not call a magnet symmetrical. It has what we would refer to as opposite ends because they attract one another. Well, it's the same thing. It's similar with molecules, but it's electric, not magnetic, and we have what we're going to refer to as dipoles. And the dipoles result from an unequal sharing of electrons, like we said at the beginning, and that's based on different electronegativities. Right? Atoms of 2 different elements will always have at least slightly different electronegativities, which means they have different desires to gain electrons, different pull on the electrons within the bond. That means the electrons are going to spend more time with the more electronegative element, and the electrons will spend less time with the less electronegative element, and what we end up with, I mentioned the term over here, a dipole. This is how we illustrate a dipole with this arrow. You can see sort of a positive here. We're going to generate a partial positive end and a partial negative end. The more electronegative element will be the more negative end of the bond. The less electronegative element will be the more positive end of the bond. 2 ways we identify a polar molecule. The first is it doesn't pass the mirror test. That's where the term asymmetrical comes in. You can see I have an X and a Y axis drawn below. And we're going to take a look at these two molecules. Actually, we have a few that we're going to look at to see if they pass the mirror test. If something doesn't pass the mirror test, it is polar. It's asymmetrical. So that's the first way we identify a polar molecule. The second is even if it seems to pass the mirror test. If there are more than two atoms and the central atom has lone pairs, that's also an indication it is polar. All right, so we'll lay this out. Let's start with an example, something concrete. And we're going to draw the Lewis structure for HCl. Here's our bond. As you can see, this doesn't pass the mirror test. I can't flip it and get the same thing. Since it fails the mirror test, and that's A number 1, that means it's a polar molecule. We can stop right there. If it doesn't pass the mirror test, it's asymmetrical. I can't flip it, then it's a polar molecule. Our second example can be drawn a couple different ways. And the first way I'm going to draw it is the way that would end up confusing a lot of people when it comes to the mirror test. If we said we've got an O, we know that O forms two bonds. It's got an H on both sides. And we draw our lone pairs. Well, that to me looks very symmetrical. I can flip this thing. It's the same as it was before. Slightly off center. Flip it. I got the same thing on both sides. However, so even if we draw it this way and we said mistakenly that it passes, the way we have it drawn, it passes the mirror test. Our second test has to do with these guys. It has lone pairs around the central atom. That means it is a polar molecule. So even if something passes the mirror test, if you identify that it has these one or more lone pairs around the central atom, then that's also an indication it's polar. Now, the other way I wanted to just draw that water molecule for you that would have been sort of a dead giveaway, if you drew the oxygen and did its Lewis structure first, and then put the hydrogens where the unpaired electrons on oxygen are, now all of a sudden you have something that does not pass the mirror test. And so the idea now, there are two different ways to draw a water molecule. One way would fail the mirror test, and you're done. That's this way over here. Fails the mirror test, so it's polar. The other way, over here, even though it passes the mirror test, it's the lone pairs that indicate to you that it is still a polar molecule, asymmetrical.